Object-oriented programming. There's no requirement that you use object-oriented programming in your class projects or anything like that, but conceptually it's something that you've actually been using all along. You just haven't been defining your own classes. So what is this? What's object-oriented programming? So we've talked about code and we've talked about defining functions when you have some piece of code that you have to use over and over again. Object-oriented programming takes one more step beyond that, and it takes you to the concept of classes. So a class is a grouping of associated data elements and methods. A method is a function which only applies to that type of object. So if I define, for example, a person object, the person object would have data, which would consist of like the name of the person and the address of the person and whatever information you wanted to store about the person. And it might also have methods which would allow you to do things to that object. So it's taking the idea of encapsulating code to another level. It's basically an abstraction, a mechanism for abstracting things to make it easier to write code that isn't going to break. So we've actually been using objects all through the class. So when we're doing image processing and we read an image from disk, we got an image object, and then we would call methods on the image object. In fact, when you make a string, you can call methods on the string. So the string is an object. The only data for a string is the string itself, so it's not a very complicated object. But when we go back to, say, the image object, when we read the image file from the disk, not only did it have the image and the image data, it also had information about the image, like how big it is and what color space it's in and when the image was taken and maybe where it was taken, that sort of thing, right? So when you read the image from the file, it produced a single object which contained lots of different information and also had methods which would allow you to do things to the image which wouldn't be useful in other contexts. So the basic idea of objects is called the class. A class definition is basically a name of the class and then a list of attributes. These are the data objects that the class is going to contain. Then an instance of the class is just the data associated with the class. So as a more complete example, if our class is person, then our attributes might be things like name, position, email, zip code, city, state, all those sorts of things. And then methods, which would be the programmatic code functions which only apply to this class. You could have things like check name or send email or something like that, things that would do something which would only be valid for this person class. Then an instance of the class, this would be like if you have the image class, when you read a particular image from the disk, that is an instance. Whereas the class is the definition of images in general. So this is abstract, this is specific. Right, how do we define classes in Python? One other thing. So classes, in a certain sense, are just like a dictionary, right? The data that you store in a class could equivalently be stored in a dictionary. However, if you store things in a dictionary, you don't get this additional benefit of being able to define functions which are only good for that particular class. So people who don't like object-oriented programming, who think of in terms of functional programming, would probably use this concept of, well, you just put your data in a list or in a dictionary or whatever, and then you write a bunch of functions which can interact with those dictionaries and lists. You lose a lot of benefits there because then you don't have you're not forced to meet any particular design criteria for the objects and such. Anyway, so this is how you define a basic class. In Python, this line, class person, is sufficient to define a new class. We'll just put it here. Okay, that is valid Python code. Get rid of the line numbers. And if I type person now, that is a person. It doesn't call it a class, but that's what it is. It is a class object. If I want to create an instance of person, I can say me equals, and you call the class as if it were a function. again, you've been doing this all along. So if I say me equals list, like that, that's the same thing. A list is an object. So I can create a person object. It's just not a very interesting object because it doesn't have any attributes or anything associated with it. But it is a valid object. Now, in a language like C or Java, or C++ or Java, when you define a class, you're required to define all of the data that's going to be associated with the instances. And you have to say what type of data each element is as well. So we'd have all these things as strings, these things as two-letter characters, an integer, etc. In Python, that's not required. Python, as we've seen before, is a lot more free-form than some of the lower-level languages like C++ or Java. So, as we learned before, when you define a function in Python, you can pass anything into the function that you want. You can pass an integer, a floating point number, a string, all into the same function. In C++ or Java, you would have to, when you define the function, you have to say what type of data you're passing in. Same thing with classes. In Python, you don't have to predefine what metadata is going to be stored in the class, so I can do something like me dot first name equals Steve. Oops, and I need a second quote. There. Now if I look at me, it's still just an object, but if I say me dot first name, it will be Steve. Right? So this is very similar to a dictionary, instead of using square brackets and quotation marks around the name of the attribute, you're using the dot notation around things. Right? So that's what's going on here. We've created a person, and now we've set various attributes, and we can print out each of those attributes if we like. Now, this isn't a good way of making a class. Ideally, you'd like to do something like this in Python as well. Otherwise, people will make a class instance, and they'll just use whatever names they like for things, and it won't really be much of a class at all. So you want to do things which actually define what sorts of data you're going to store. So typically, while I can set a value by just saying me.firstname equals Steve, typically when you define a class, it's a good idea to use setters and getters. So if you want to change the name, you would define a method in the function called setName and another method in the function called getName. And that would allow you to do things like, let's say, make sure that the first and last name are capitalized properly. So if I just say me.firstname equals Steve, then it's just set to that value and there's no opportunity for the class to do anything to it. If I define a function, a method called setName, then inside that method I can call this fixCase method to fix the capitalization of the first and last name, for example. So let's go ahead and do this. So we're going to take this code. Actually, that's not all of it. Then the next page here, we'll define some other methods. All right. So there are some interesting things going on this page. So here, I have this. I'm calling this fixCase function, but it's not defined until down here. So here's the fixCase function, which is just going to use title case for both the first name and last name. Here I have this function that says underscore underscore init underscore underscore. I know this looks like a solid line, but that's two underscores together. Whenever you see a method in Python which starts with double underscore and ends with double underscore, it has some special meaning to the Python language. So init functions allow you to define how you initialize the object. So I can provide a bunch of parameters to the init function here. Did I already copy the code there? No, let's do that. So let's talk about it in the context of the Jupyter Lab session. Okay, so we'll go ahead and run that. So now I've defined my new class. All right. So the init function is basically saying when I initialize my person object, I want to be able to pass in first name, last name, address, etc. to initialize the object. And then here inside the init function, it's actually going to assign that to self.firstname, self.lastname, self.address. So all of these Python methods, all of these class methods, the first parameter to each of the methods is self. So when you call any of these methods, you're calling them on an instance of the object. So when I created the object me is the instance. So if I say me dot get name, self is going to be set to me when it runs this code. Okay, so let's give this a try. So again, so I can still do me equals person. Now if I print me, what am I going to see? Oh, none dot none dot. So what's going on there? So I defined an init function, and I have default values for all of these parameters. This way I know that all of these different metadata items are going to get initialized in the object, and I've defined what all of their names are going to be. So this is sort of the equivalent to the C++ definitions here. I don't have to define what the types of the variables is going to be, but at least I'm giving names to all the variables that I'm going to use conventionally in the object. So if I don't pass in any of these parameters, then it's just going to set them to defaults, which is none. So what caused all those nuns to get printed out? Well, here's the special repr underscore method. repr says what is going to happen when you print the object out. What's the representation of the object when you display it? So I can put whatever I like in there. Here I can return. Basically I'm returning a string that I'm constructing, which contains the contents of the object. If I define a get item, this is going to make the object look like a list. So I can, if I define an underscore get item method, then I can use square brackets with me, and I'll get results out. So let's do a little bit more here. So I'm gonna say first name, last name instead. I'm going to initialize it properly. We'll stop with that. Oops. What did I miss a quote somewhere? Oh, yeah, thank you. That's better. Well, it would be better if I put quotes in there. There we go. Oh, and I have an extra. Yeah. Oh, actually, that could be an integer, or it doesn't matter at this point. So that's fine. All right, now if I say me, I'll get out that. Now, you'll note that it didn't do the fixed case thing, and that's because when I defined the function, the init method, I didn't put fixed case at the end of the init method. Now, if I say me dot fixed case, that won't return anything. And now if I look at me again, now the case will be fixed. So when fixed case gets called, it gets called with self, which is set to me, and then it can modify the contents of the object. But when you're modifying the contents of the object, you always have to use this self dot, because it wants to change the values associated with that particular instance of the object. Now what about this get item thing? So you can see what I did here. I said if key equals 0, then it's going to return this string. If key equals 1, it's going to return this. Key if equals 2, and if it's any other key, it's going to raise an index error. So let's say me of 0, and it'll return first name, last name, me of 1. So I can do anything I want with this. I can basically redefine the behavior of the square brackets for purposes of my object. And you'll find that a lot of the classes that we've already used in the class do that kind of thing, right? When we're doing some of the bioinformatics stuff, the sequence objects would redefine the meaning of a lot of these sorts of things. So you could do novel sorts of operations. So the same thing is true. So get item allows you to modify the behavior of when you retrieve a value with a number in the square brackets. There's also set item, which is what happens when you assign a value with square brackets. Then there's other methods for dealing with dictionary-like behaviors and that sort of thing. So pretty much any behavior that exists in one of the standard Python objects you can emulate by defining an appropriate double underscore method that's associated with it. So you can do all sorts of fun, complicated sorts of things with this. Setters and getters, methods. Okay, inheritance. So one of the most powerful aspects of object-oriented programming is, let's say I've gone through a lot of effort to define this person class, which is nice and robust and it has all these parameters and stuff like that, but now I need to add something to it. So for example, I want to have a BCM person, and I also want to store the ID number, the badge number associated with that person. Now I may still have other people which aren't BCM people. You know, maybe you've got a system for the medical center and it has people from Baylor and it has people associated with UT Health, and UT Health uses a different structure for their IDs than Baylor does, so you have to have BCM people and you have to have UT Health people, and they have to have different properties. So what we can do is we can say, when we define our class, if you put something in parentheses here after the name of the class, it will base the new class on the old class. So it'll take everything you've already defined for the person class, and BCM person will inherit all that stuff. And then you can override or define new additional things. So here, these set BCM ID, get BCM ID, those are new. And here, I'm replacing the REPR method that existed in the original class with a new REPR method. So if I do this, let's do it here. It doesn't matter where I put it as long as it gets executed. And now, instead of making me a person, I'm going to make me a BCM person. And I'll say me dot set BCM ID and now if I say me, it will also print my ID number. Okay? So this allows you to take existing classes and make your own versions of them that have specific behaviors. In Python, you can actually even do things like create derived classes for things like dictionaries. Let's say you have a dictionary class, and you need to modify the functionality of the dictionary in some way. For example, let's say you want to make sure that all the values are unique as well as all the keys being unique, or something like that. You can actually make a subclass of the dictionary class and just then implement the specific changes that you need to make, and you'll inherit all of that existing functionality which already works for the object. All right, we need to talk about scope now that we've talked about classes again. You remember when we had our discussion about scope, and we had the global scope, and then we had the scope inside functions. When we have classes, this gives another layer to our scope questions. So let's take a look at this block of code. Won't run it yet. So we're defining a class ABC. Inside the class ABC, I'm setting XYZ to 10. I define an init method, which doesn't take any parameters, but it sets the QQQ attribute to 5 in the newly defined instance. And I have another function that I'm defining here, which will print these three things out. It'll print out self.xyz, it'll print out abc.xyz, and it'll print out xyz. Now at the global scope, I'm defining xyz is equal to 5. Then I create an instance of the ABC object called x, and I create another instance of the ABC object called y. I set xyz in the x instance to 15, and then I call f on the x instance and on the y instance, and then I put this print statement. Oh, okay. Let's take a look at all of this. So after all of this code here, the first thing I'm going to do that's going to cause a print to happen is this x.f. So if we look in here, x.f, it's going to print this f thing here that it's going to print self.xyz. What do you think the value of self.xyz is going to be here? One possibility would be that it's going to be equal to 15. Because here I'm setting the value of the x instance xyz to 15. So when I get here, that should be the case, right? So self.xyz should be 15. Now what's abc.xyz? ABC is the name of the class, not the name of the instance of the class. So it turns out that you can define variables which are for the class as a whole, not just for instances of the class. Okay, these in C, this would be C++. This would be known as a static variable. So this is a variable that's associated with the ABC class. So that should be 10. And then we have XYZ. What's XYZ going to be equal to? Is it going to be 5? Is it going to be 10? Is it going to be 15? So let's start with that. I won't do the other two lines yet, and see what we get. So we got 15, 10, 5. So 15 was exactly what we expected. It was the 15 from here. 10. That's again what we expected, because here we've defined XYZ for the class to be equal to 10. And XYZ here is 5. So here, it got the XYZ from the global namespace, not from the class namespace. Okay, let's try the next one. What's going to happen with Y? So with Y, I did not have an equivalent line to this. So I created a Y instance, which doesn't have an XYZ value itself. Nothing ever set Y.xyz to anything. So is it going to get this value, or is it going to get this value? What's going to happen when you try to access self.xyz here? 10. So it gets the value from the class. So the search order, when you try to get self.xyz, when you try to get a variable from the instance, if the instance doesn't have that variable, then it'll check to see if the class has the variable. And if the class has the variable, then it will use the class variable. If it doesn't find one there either, then you'll have a problem. All right, last one, which is what do we see out here as the value of each of those things? And again, we'll see, so for x.xyz, we see what we expect to see from here. Y.xyz, it does the same thing that it did in here with self.xyz. It gets the class variable if it doesn't exist for the instance of the class. And xyz is, wait, why is xyz, oh sorry, this is abc.xyz, sorry, yeah, right. So abc.xyz is 10. So the class variable is 10 there. So there's a lot more subtleties associated with scope and inheritance when you start dealing with classes. And there are some subtle tricks that may go on. Just keep in mind that each instance can have a different value for each variable, and that if there's a class variable and you change the instance variable the same name, it just changes it in the instance, it doesn't change it for the class. So let me do one other thing just to further muddy the waters. Let's say I say abc.xyz is equal to 99. And then let's do this again. Okay, so now x.xyz is still 15 because that variable was set for the instance, but y.xyz, which is drawing from the class variable, has now changed to 99. And of course abc.xyz, since I just said it, is 99. Okay? So this is just what I was telling you, basically. Now, I didn't cover everything about classes, obviously. Classes are a very complicated topic. We didn't talk about class methods. So there are methods you can define that are in a class that don't work on instances. They work on the class itself. Then there are other special methods, which I showed you examples of a couple of the special methods to override certain behaviors, but there are a lot more of them for dictionaries and other aspects of the program. All right, so that's our quick introduction to object-oriented programming.